Alrighty, we're going to do a little reminder of Soh Cah Toa, sine, cosine, and tangent. Sine is OA, opposite over hypotenuse. Cosine is A over H, which is adjacent over hypotenuse. And tangent is opposite over adjacent, or O over A. So once you have that, we now have to set these up. So if I want to know sine A, you have a triangle here, this is angle A. Sine A would be opposite over hypotenuse. So opposite of this angle would be BC, and hypotenuse is always opposite the 90, so that's AB. So sine A would be B side BC over side AB. So again, this is your angle, this is your opposite, and this is your hypotenuse, according to sine. So we have sine angle B, we start here, and opposite of that would be AC, but the hypotenuse is still AB. Hypotenuse is always opposite to 90 degrees, and it's the longest side. So that one would be AC over AB. Again, because from this angle, this is opposite, and this is hypotenuse. So if we want cosine, we want adjacent hypotenuse of angle A. So if this is angle A, adjacent would be the one right next to it. Even though this is next to it, that's the hypotenuse. So for cosine, I want the adjacent over hypotenuse, so that would be AC over AB for angle A. So we have, that would be again AC over AB. What would be cosine of B? Well, this angle, adjacent would be BC, and hypotenuse is still AB. So that one would be BC over AB. All right, let's keep going. Tangent A. So what's the tangent of A? Tangent is opposite over adjacent. So if this is your angle, opposite is BC, adjacent is AC. So what we have there is now, it would be BC, which is your opposite, over AC, which is your adjacent. And for angle B, opposite is actually AC, adjacent is BC. So for that one, it would be AC is opposite, and your adjacent to angle B is BC. So remember, Soh Cah Toa. Make sure you know these three things to set them up of any triangle, right triangle, not any triangle, any right triangle, and you can choose either angle to reference. You can't ever do sine of C. It doesn't make any sense, because that's the 90-degree angle that you're using, what's named off this 90-degree angle C. Okay, so there's another question we might ask, is what if I said, what is AC? Is there a way to rewrite any of these to find AC? Well, if I want to solve this for AC, well, what I can do to find AC, what I could do, if I want to know what AC equals, could I say sine B is equal to AC over AB, and then could I multiply both sides by AB? That disappears. So wouldn't AC equals side AB times sine B? So would that be the answer to AC? Could you find it doing that? But you could also use this one. Could you also use this one right here and go, oh, could I also see it as cosine of A is equal to AC over AB? And then from there, can I multiply both sides by AB? That disappears. And could I say that AC is also AB times cosine A? That is also equal to AC. There's different ways to find AC. Could you also use this one, which is a little bit uglier? Watch what happens with this one. I can use this tangent. This is where it gets a little bit tricky. If I say tangent A is equal to BC over AC, how do I get AC by itself? Well, the first thing you do is multiply both sides by AC. That's gone. So I have AC times tangent A equals BC. Then here's where it gets tricky. I have to divide both sides by tangent A. That's gone. And I now have AC equals BC over tangent A. And I could also do this one and solve for AC. You could find AB, BC, any of the sides, using any of these to start with. So if I wanted to find BC, I could use this one, because it has a BC. I could use this one. I could use this one or this one. And then I just solve for BC, but it also depends on what sides you're given. a lot of times you're maybe given this side and this angle, or this angle and this side, or it just depends on what's given. So you have to kind of look at what's given to be able to figure out what you need to set up and maybe solve for. Good luck with it.